Welcome students. It is our second lecture of chapter second, real number. In last lecture we learned about types of numbers and rational numbers, the properties of rational number, decimal form of rational number and p upon q form of rational number. मागच्या तासाला आपण परिमेय संख्या म्हणजे काय बघितलं, परिमेय संख्येचे गुणधर्म आणि दशांश रूप बघितलं. Today we have to learn about irrational number. आज आपल्याला अपरिमेय संख्या शिकायचं. The numbers other than rational numbers are called irrational numbers, like radicand 2, radicand 3, radicand 5, radicand 7, value of pi. These are irrational numbers. या सर्व अपरिमेय संख्या आहेत. How we can prove that these are irrational number and not rational numbers? आपण हे कसं सिद्ध करू शकतो की ह्या अपरिमेय संख्या आहेत आणि परिमेय नाहीत. So let's we prove the first, that is radicand 2 is irrational number. We prove it by indirect proof. आपण अप्रत्यक्ष सिद्धतेद्वारे हे सिद्ध करणार आहोत की कर्णित 2 ही अपरिमेय संख्या आहे. Let us consider radicand 2 is rational number. Rational म्हणजे काय, तर परिमेय संख्या. आपण असं गृहीत धरतोय की कर्णित 2 ही परिमेय संख्या आहे. If it is irrational number, therefore radicand 2 it is written in the form of p upon q. कारण परिमेय संख्या ही p छेद q च्या स्वरूपात लिहिली जाते, where q is not equal to 0. हे आपण शिकलो. And by this we know that p and q has 1 as only common factor. 1 as only common factor. That is number 1. जर p छेद q स्वरूपात ही संख्या असेल तर p आणि q मध्ये दोघांमध्ये फक्त हा एकच सामायिक अवयव आहे. ओके. Now on squaring on both sides we get 2 is equal to p square upon q square. Squaring on both sides. Squaring on both sides म्हणजे काय, दोन बाजूला वर्ग केला असता कर्णित 2चा वर्ग 2 p वर्ग छेद q वर्ग. We can write as p square is equal to 2q square. म्हणजे p वर्ग बरोबर 2q वर्ग. Means we can write p square is even number. And we know that if p square is even number, then p is also even number. p is also even number. p square जर समसंख्या असेल तर p सुद्धा समसंख्या असते आणि 2 त्या संख्येचा अवयव आहे. So we can write p is equal to 2t, therefore p square is equal to 4t square. p square is equal to 4t square. So if we put the value, that is 2q square is equal to 4t square, and therefore q is equal to 2t. q is equal to 2t, like p square is equal to 2 square. Okay. How we write here 4t square? Because 2q square is equal to p square and value of p is 4t square. So q is 2t, means we can write that q is also 2 is also a factor of q. Means q is even number. q square is even number. q is also even number. q वर्ग ही समसंख्या आहे म्हणून q सुद्धा समसंख्या आहे. Therefore 2 is factor of q. 2 is factor of q. Now 2 is a factor of p and 2 is factor of q. Therefore we can write p and q as common factor. Is 2. The common factor of p and q is 2. That is number 2. If we observe the first statement and second statement. In first statement, we state that P and Q has one as only common factor, and here we write P and Q has two common factor, two as a common factor. And this is in contradiction. That what we assume. We assume that it is a rational number. In rational number, only one is the common factor. So P and Q, therefore P and Q is not, so radicand 2 is not rational number. And if radicand 2 is not rational number, then it is ultimately irrational number. Therefore, we can write radicand 2 is irrational number. Radicand 2 is irrational number. जर कर्णित 2 ही परिमेय संख्या नाही तर कर्णित 2 ही अपरिमेय संख्या आहे. Similarly, we can state about radicand 3. If it is radicand 3 is there, same P upon Q. Instead of radicand 2, it is 3. Therefore, we can write the factors of 3, and we can state similarly as radicand 2. We can state that radicand 3, radicand 5, radicand 7 are irrational numbers. Okay? You can pause the screen and write the same. Similarly, the other irrational numbers are, like suppose 2 plus radicand 3. Show that this number is irrational number. We can again say that let consider 2 plus radicand 3 is rational number. And if it is a rational number, then 2 plus radicand 3 is equal to P upon Q. जर 2 अधिक कर्णित 3 ही परिमेय संख्या असेल तर ती P छेद Q स्वरूपात लिहिता येईल. And now we can say that radicand 3 is equal to P upon Q. Plus 2 is plus on this side, on other side it becomes negative. We get this. And if you observe this, the left hand side is irrational number and right hand side is rational number. And irrational and rational number never can be equal. So it is in contradiction. So we can say that 2 plus radicand 3 is not rational number. And if it is not a rational number, then it is ultimately irrational number. जर 2 अधिक कर्णित 3 ही परिमेय संख्या नाही तर ती कोणती संख्या असेल? अपरिमेय संख्या. Therefore we can write 2 plus radicand 3 is irrational number. If the example is changed, suppose 2 plus radicand 3, in case of we can write 4 minus radicand 5. We can write 7 minus radicand 7. We can write 4 into radicand 3. Any number can be changed and we can easily solve by this simple method. Okay. Now, in last lecture, we learned the decimal form of rational numbers. Now here we have to learn decimal form of irrational number. मागच्या लेक्चर मध्ये आपण परिमेय संख्यांचं दशांश रूप बघितलं. आता इथे आपल्याला अपरिमेय संख्यांचं दशांश रूप बघायचं आहे. To write the irrational numbers in decimal form, we have to use the division method. How? We take the example which is not in book, that is suppose decimal form of radicand 5. If you have to write decimal form of radicand 5 in book, decimal form of radicand 2 and radicand 3 is given. We have solved a different example from the book. We have to write 5 and we have to divide it by the numbers. Like suppose we have to divide 1, then 1 into 1, that is 1. After 1, 2 is come. 2 into 2, 4. After 2, 3 is come. 3 into 3, 9. So it is greater than 5. So we can write 2 because 2 into 2, 4. We multiply it by 2, so we add 2. We get 5 minus 1, 1, 2 plus 2, 4. Now 1 is not divisible, so we take the zeros. Now the next procedure is carried out by. Here we take decimal point. If we write 1 here, we have to multiply by 1, 41 into 41. It is very less than 100. If you write 2, we have to multiply by 2, 42 into 2, 84. If you write 3, 43 into 3, that is 129. It is greater than 100. So we write 2 here, 2 into 2, 84. We multiply by 2, so we add 2. It becomes 2 plus 2, 4, 44. 100 minus 84 is 16. Next, 2 zeros are there. 1016 is there. Now, simply here, if we take 0, if we take 1, we have to multiply by 1, 441. If we take 2, we have to multiply by 2, 884. If we take 3, and suppose if we take 4, 4 into 4, it is absolutely greater than 1600. So the maximum is 3. So multiply by 3. So here we also add 3. 3 plus 3, 6, 4, 4. And here multiplication process, 3 into 3, 9. 3 4s are 12, carry 1. 3 4s are 12, carry 1 is there, so 13. Subtract this. 10 minus 9, 1. 9 minus 2, 7. 5 minus 3, 2, 0. Again 2 next zeros. Now 4, 4, 6. If we put 1, we have to multiply by 1. If we put 2, we have to multiply by 2. Now in 4 table, 4 6 are 24. 24,000 are there. So we multiply by 6. So we add 6. So here we write 6. 6 plus 6, 12, carry 1. 6 1, 7. 4 4, 7 2. And now we multiply by 6. 6 into 6, 36, carry 3. 6 6, 36 and 3, 39, carry 3. 6 4 are 24, plus 3, 27, carry 2. 6 4 are 24 and 2, 26. हा गुणाकार समजत असेल, 6 6 36, 6 हाच्याला 3, 6 6 परत 36, 36 आणि 3 हाच्याला 3 होते 39, परत हाच्याला 3, 6 चौक 24 आणि 3 27, हाच्याला 2, 6 चौक 24 आणि 3 हाच्याला 2 26. इथे वजाबाकी करताना 10 तून 6 गेले 4, 9 मधून 9 गेले 0, 10 तून 7 गेले 3, 7 तून 1 गेला, 7 तून 6 गेला 1, 1304. We can carry this like, okay, it will never end, it will never end. And suppose similarly decimal form of radicand 7, we have to find decimal form of radicand 7. आता 7ला आपल्याला दशांश रूपात, कारण 7 ही दशांश रूपात मांडायची. याच प्रोसिजर 1 into 1 very less than 7, 2 into 2 4, 3 into 3 9 greater than 7. ही 7 पेक्षा मोठी आहे, 3 त्रिकण 9, म्हणून इथे आपण किती घेणार 2, 2चा भाग केला, 2 दुणे 4, 2 गुणलं म्हणून 2 प्लस 4, 2 2 4, 3 आलाय, 3ला भाग जाणार नाही म्हणून 00. इथे 1 घेतला तर एकाने गुणावं लागेल, 41 1 41, 2 घेतला तर 42 2 84, 3 घेतला तर 43 3 129, 4 घेतला तर त्याप्रमाणे आपल्याला माहिती 7च्या पाड्यात 7 4 इन 7 28, 4 7 28. If we take 4 7 28 for an example, 7 7 7 7 49, carry 4, 7 4s 28 and 4 3. It is greater than 300. So instead of 7 we have to take 6. We take 6, so we add 6 and division also of 6. 6 दूने 12, carry 1, 52. Here 6, 6, 36, carry 3. 6 for 24 and 3, 27. 10 minus 6, 4. 9 minus 7, 2. 24 is remain. Now next two zeros, 2400. Here 52. If we take 1, multiply by 1, एक घेतला एकानेच गुणावं लागेल 521 एक 521. 2 घेतला तर 2 ने गुणावं लागेल 522 गुणिले 2. पण आपल्याला इथे दिसतंय 2400. 50च्या पटीत 500च्या पटीत 4 घेतलं की 2000 येतात. 5 येऊ शकत नाही कारण 5 2500 होतील. म्हणून ते आपण 4 ने मल्टिप्लाय करू. तर 4च मिळवायचं इथे. 4 मिळवल्यानंतर 8, 2, 5, 528 and multiply. 4 4s are 16, carry 1. 4 2s are 8, 9. 4 5s are 20. So we get परत 10 minus 6, 4. 9 minus 9, 0. 3 minus 0, 3. We again take two zeros. Again here we have to 1, multiply by 1. 2 multiply by 2, 3 multiply by 3, but very simple. Suppose 5000 are there, here 30,000 are there. 5 6 are 30. So 5000 6 are 30,000. So we cannot be multiplied by 6 because it is more than 30,000. So here we are multiplying by 5. Okay. So here we also add 5 minus 5 5 10, carry 1, 8 and 1 9, 5290. Now multiplication 5 5 25, carry 2. 5 8 40, 40 and 2 42, carry 4. 5 2 10, 10 and 40 14, carry 1. 5 5 25, 26. गुणाकार इंटू म्हणजे गुणाकार. 5 5 25, 5 हातच्याले 2, 5 8 40 आणि 2 42, हातच्याले 4. त्याप्रमाणे आपण गुणाकार केलाय. आता इथे वजाबाकी करू. 10 तून 5 गेले 5, 9 तून 2 गेले 7. हियर 13 तून 4 गेले 9 आणि इथे 9 तून 6 गेले 3. 3975. We can carry this for a long. If we observe both the examples, the decimal form of irrational number is non-terminating and non-recurring. Decimal form of irrational number is non-terminating and non-recurring. हे त्यांचा भागाकार संपत नाही, अखंडित आहे. आणि नॉन रिकरिंग म्हणजे अनावर्ती आहे. पुन्हा पुन्हा त्या संख्या येत नाही. एक लक्षात ठेवायचं, अपरिमेय संख्यांचा दशांश रूप हे अखंडित अनावर्ती स्वरूपाचे असते आणि परिमेय संख्यांचे खंडित किंवा अखंडित आवर्ती स्वरूपाचे असते. ओके, वी विल मीट इन नेक्स्ट लेक्चर. अंटिल देन, गुड बाय.